Welcome to November 17th LeetCode Challenge, Rectangle Area. Given the coordinates of two rectilinear rectangles in a 2D plane, return the total area covered by the two rectangles. The first rectangle is defined as bottom left corner, AX1, AY1, and its top right corner, AX2 and AY2. The second rectangle is defined by its bottom left corner to be bx1 and by1, while its top right corner to be by2 and bx2 and by2. So we have a diagram here. We've got two rectangles here, and we want to find basically the area of which it overlaps. So let's kind of look at here. We have ax1 being coordinates of -3 and ay1 being 0. So -3 and 0 is this point right here. We have its point 2 would be ax2 and ay2, which is 3 and 4 respectively. And then you have by1, bx1 and by1, which is -0, -1, which is this corner here. And then we have bx2 and by2, which is 9, 2, which is this corner here. And therefore, you're given those kind of four coordinates, and then you're going to make a rectangle out of them, and then find the overlap between them, and then you need to find the area of that. Let's see. Oh, you want to find return the total area covered by the two rectangles. So find the entire area basically. So you do want to count this once only. There's an overlap, and you want to count that once. And similar to this example here. And all the values are between -10 to the 4 and 10 to the 4. Alright. How do you go about solving this? So essentially at the end of the day, this is a math and geometry problem. So basically what we want to do is, in this problem, we're given the coordinates of 4 points on a 2D plane. 2 of them belong to the bottom left and top right corners of rectangle A, and then the other 2 points belong to the bottom left and top right corners of rectangle B. The sides of rectangles are parallel to the x and y axis as given as such. So that's by using these points, we define the total area covered by both rectangles. So without, an indicative diagram as such, you can want to think about it in terms of simply adding the two individual areas of both rectangles, and that would be a common mistake because two rectangles can potentially overlap. And considering this, let's see how we go about solving this problem. So for instance, if we overlap completely too, so for instance, we have the rectangle A and rectangle B being the same coordinates, therefore the area would be just of one of them. So basically what we want to do is calculate both areas of the rectangle. So let's kind of break this down to a couple of steps in our algorithm. Say we have step number 1, we're going to calculate the total area covered by the two rectangles. That should be easy enough. Next thing you want to do is calculate the area of the overlap. The area of the overlap between the two rectangles. Alright, next thing I'm going to do is subtract the overlap from the total area. Subtract the overlap from the total area. So this is going to be our algorithm. So the tricky part of this algorithm is basically how do we know what the overlap would be? Because if you're given this area here, right, this overlap, this is not within our data point that we're given as we pass through a parameter. So that means we have to find it and find that total area. So basically that total area of at point 00 to point 32. So basically, you need to find the overlap on the y-axis separately and the x-axis separately, and then using this. So say, let's draw a little bit of a diagram here. So say you have case 1, right? Let's see, case 1. You have the following: ax1, which has a line as such here, ax2. I'm just going to try to copy it. Let's see if I can. So say you have something like this. Tab, tab, tab. So in case 1, we have just basically a hang overlap. So therefore, A, X, and BX are overlapping, but there is a bit of A and then there's a bit of B left over. So therefore, it's kind of like this overlap right here, right? Where there's a bit of A and there's a bit of B. Case number 2, where we have one rectangle, say for instance B, A completely overlaps B, so therefore everything inside B will not be counted, only A will be. And then case number 3, where there is no overlap, so therefore we have to calculate both the area of A and B. And then you kind of draw this conclusion to the y-axis as well. And then ideally this is like a linear format, but then if you do it in the area format, then that'll be basically fine there. So if you just kind of draw all the cases for draw the cases down for A and B, you find that there's about 10 cases in general, and if you swap A and B, there's only 3 cases as shown above. So basically what we want to do is find the minimum of the 2 endpoints. I'm going to maybe copy this out if I can. Oops. So say we want, let's kind of erase this. So in order to find the overlap, what we want to do is find the minimum of the 2 endpoints. We want to also find the maximum of the 2 start points. 2 points. Then we want to find the overlap, which is basically, let's call this 1, call this 2, which is basically 1 minus 2. So we have to note that the negative results are negative, then that means that there's no overlap. Then if there is, and then also the overlap is 0 if basically you have to take care of the edge case of 0 as well. So let's define the following. So let's define a function that finds the area, and that's going to take in x1, x2, y1, no, y1, x2, y2. Alright, you define a function that finds the area, and we're going to return the area of a rectangle. Now, if you recall from basic math, the area of a rectangle is x2 minus x1 times y2 minus y1. So far, so simple. Next thing we want to do is find the overlap. So that's our function. Now we want to find the overlap. So basically, let's call this X overlap. And that's going to be the maximum between the minimum of AX2 and BX2 minus maximum between AX1 and BX1. Obviously, we have to take care of the edge case where we have an overlap of 0 as well, so therefore we make it up to 0. So either we find a maximum or it's 0. It can't be negative. Next thing we're going to do is do a very similar thing. Now we find the y overlap. And it's going to be the maximum between the minimum of AY2, BY2 minus maximum between AX2, AY2 I should say, and BY1. That should be 1 as well. That should be a comma. And then take an edge case of 0 as well if there's no overlap. So once we have the overlaps, we basically return the following. Return the area of AX1, AY1, AX2, AY2 plus the area of BX1, BY1, BX2, BY2. Alright, and let me see. AY1, BY, okay, good. And we want to minus the overlap. Minus the overlap, I should say, from minus the overlap of X overlap times Y overlap, which is the rectangle of the overlap. Alright, that was lengthy, but I hope this works. Alright, looks promising. Nice. So basically this runs a big O constant space, and memory complexity is big O of constant space as well. Constant memory, I should say. Linear time complexity, constant time complexity and constant memory usage as well. Excellent. Alright. And obviously you could just, let me see, you could probably make this a one-liner by taking this right here. Yeah, I can make it one-liner too by substituting all the following variables, but those look a little bit nicer. Alright, I'll stop there for today. Have a great day.